All right, yesterday we talked about even function, odd function, and we also have done, we did some examples outside the trig function, and then we look at the trig function. I have assigned you guys homework. Have you guys tried the homework? Have you guys tried the homework? Do you have any questions on the homework? So this is a sign. This is the sine curve. As we talk about, this is an odd function, right? When the inputs are opposites. When the inputs are opposites, their respective output are also opposite. That's what we observe. Yesterday I drew some, I think I drew some curve with the Zoom software. So here I put these features in here. As you can see, when the input, right, this is X and this is negative X, right? Their respective output, right? So this is going to be, this is going to be f of negative X. And this is going to be f of X. Okay, so these two are opposite to each other. If I flip this one, if I put a negative sign in front of f of X, what will happen is that if I put a negative sign in front of the red, it will become the green because it's the opposite. In that case, that's going to be negative of f of X. You guys see that? That's the feature of odd function. And this negative f of X and f of negative X, we know the difference between these two, and these two are the same. Okay, so in odd function, when we wrote down something like this, that's the geometric meaning of that statement. Okay, that's the geometric meaning of that statement. Any questions so far? Any questions? Yes, are there any questions? Here, I intentionally, put X on the left side and negative X on the other side, just to show you that they're not necessarily X itself is always positive. X itself may be negative. Okay, so we must be mindful of that. Okay, so another scenario I like to draw for you, it would be it's the same situation, right? Same situation. If this side is X, right? I'm going to remove that X. I'm going to remove that color. Okay, I'm going to remove that color. I need a different color. Okay. If this side is X, okay, and this side will be negative X, they're always opposite. Okay, so you could be X on left, it could be X on the right, but the other side will be the opposite. So in that case, the red will be f of X. Okay, and this piece, this red piece under, is going to be f of negative X. Of course, this point, right? These 2 points can be marked, respectively. These 2 points can be marked respectively. And now you can see that the two reds are opposite. They're opposite, right? They're the same value, but opposite to each other. So they have the same absolute value. So when I put a negative sign in front of f of x, right, like this one here. So there are all these different ways you can present this, right? So I can put, if I put a negative sign in front of that, geometrically, what will happen? A will turn to be the green. Okay, this green is going to be the negative of f of x. You guys follow me? And now this green and this red will be the same. And that's describing that situation. That describes that situation. Okay, another situation, which is describing the same thing, right? Is that I can flip this guy over. Okay, I can flip that guy over. So that would turn into, if I flip this red over, it becomes its opposite. Right, so we understand what opposite is, right? So when we flip that over, that becomes negative of f of negative x. So this time the purple and the red will be the same. Okay, the purple and the red will be the same. So if I am to write it down, it's negative of f of a negative x, that's the algebraic expression, equals to the blue, which is f of x. What is this? This is just another form of the green we circled here, because you can just multiply negative sign on both sides, you're going to get a negative of f of x. So this piece and that piece in green, circled in green, right? So these two pieces, they're the same thing. They're the same thing. Okay, so there's all these different ways you look at this. You can have, and as a result, you get a variety of algebraic form of them. Variety of algebraic form of them. This is to write it in general form f of x. But now we have sine x. We have sine x, right? Are you guys paying attention with me? This stuff, if you understand, if you follow me, it's I don't know, if you give me feedback, okay? Now, if I put a sign in it, if I put the concept of sign in it, right? So now f is the rule, well, because we're working on the sine, the sine curve, right? So we have all these different forms. Right? Let's summarize this piece so far. Okay? So I want you guys to write it down. Maybe you want to have the color too, okay? And I'm going to draw two things. With the software. Okay, one is the green piece and one is the purple piece. So I'm going to draw that. I'm going to draw these two pieces. Okay, so I'm going to draw these two pieces. All right, so okay, so I'm going to make this purple. Okay, you guys take your time to take notes. And that piece, I'm going to make it green. Okay, so this piece, I'm going to make it green. So the same color as we just saw. Okay, but by doing so, okay, we will have the, I'm going to clear all of these. Okay, so that way it's one software produce all of these. Right, so previously, and this piece is, you know, f of, however I mark it three situation, which tells if it's an odd function, there's three different forms you can write it. Okay. If it's, if, okay, f of x is an odd function. Is A or N? Is A or N? I think it's A. Is a odd function. Am I right? How's my grammar? Okay, if f is an odd function, so you can write it this form because this will be true, right? That will be true. That would be true, which I just show you, right? It could be either side. It could be either side, the algebraic form. So you need to understand the geometric form and the algebraic form. Do you guys follow me? Any questions so far? The second form would be f of x equals to negative of negative x. Okay, and of course, for all the x in the domain by definition. So this is another form. And the third form, no, I think we just have these two. Yeah, these two forms cover them all. These two forms cover them all. So do you guys have any questions?
Are both of these true?
I'm sorry? Both of these
true?
are true. It's just a different algebraic form. Both of these are true. They're just different algebraic form. Okay. So the first one, what's the meaning of the first one? Okay. The meaning of first one. Let me do this again. Okay. The first case, what it means, right? What it means. If I assume, I know you guys probably have never seen this, right? Or seen this not being explained, right? Okay, so please pay attention. Okay, all of these things, if your professor can typically write them down on the screen, on the blackboard, on the whiteboard, in your math classes, and they expect you to know this. They expect you to know this. Okay, what it means, right? There's the first scenario, right? If this is x, okay. If this is x, and the other side is opposite of x. If this is x, this is the f of x. Okay, so this red is f of x. I make these two red the same color. Maybe that's confusing. Maybe I should make them different color, should I? The two red bars, they're the same color. Maybe they should be opposite. They should be different color. Don't you think? Because they're not exactly the same. They're not exactly the same. Okay, so I'm going to change this guy to purple. Yeah, when I try to make a color tone, sometimes my choice, as carefully I have considered them, right? So let's look at the first red. Right. 0, 0, 5/4. So I'm gonna make this purple. Okay, purple. How come that color? That purple that is purple or magenta. There's a slight difference. Okay, so this is better. Okay, so this is how to read the graph. Read the graph. Okay, so if this is x, then the other side will be negative x. They are opposite, right? For the x, the output is the red. For the negative x, the output is the purple. But how do you express it? So this purple height over here, okay, that purple height over there is written as f of negative x. You guys follow me? So this purple here and this red over here, they are opposite to each other. In the case of odd function, we're describing the meaning of the odd function. Okay, the geometry and the visual, the geometric description and the algebraic expression. Okay, and the algebraic expression, right? So this one shows the input is x, the output is f of x, right here on the dot. And this one over here, the input is negative x, the output is f of negative x. So these two dots, right? So this dot on the top, I'm pointing to. This dot is negative x. That's the input. And the output is f of negative x. No, if you haven't learned this before, it's hard. It's hard to understand. You guys have to work with me, okay? The next one is, because this is x, right? This is the f of x, so that's x f of x. In the past, you guys always learn how to do x comma y, right? X comma y. But not everything is always expressing x comma y. In the calculus setting, or even in these classes, sometimes those are not sufficient. You have to specify what x is and what y is in settings like this. You follow me? So now this is x f of x, right? So this is x f of x. And this is a negative x, this is f of a negative x, right? So input, output. That principle doesn't change. That principle doesn't change. And these are the two dots. So the purple and the red, okay, this purple and this red are of the same length, but opposite in sign. Okay, so the red and the purple, they're the same length, but opposite in sign. It's like negative root 2, positive root 2. Negative 1/3, positive 1/3. You guys follow me? They're opposite to each other, but their output. Output is a vertical measure. The vertical measure. Now, if I flip the red over, what happens? This guy, f of x, is turned into what? Turned into its opposite. So that's the algebraic expression. Do you guys follow me? One is the visual, right? The red, this red turned into the purple, all right? And the negative, so because this red is f of x, you put a negative sign in front of it, becomes negative of f of x. You follow me? So next, I'm going to make another change. I think this way probably is, I'm going to turn the green to red. Okay, I'm going to turn the green to red. So this way they will be consistent, okay? So for you guys to compare. So what the definitions say here is f of a negative x is equal to negative of f of x. What is saying f of a negative x, which is this guy, is the same as negative of f of x is this guy. There's this statement Okay, so this statement is saying these two are equal. That's what they're saying. You follow me?
So, so negative of f of x is the same as f of minus x.
Right. When the input are opposite, the output are opposite as well, using the mathematical notation.
This is for the odd function.
I'm sorry?
This is for odd.
Yes, we're talking about odd function, the feature of odd function and its various form of algebraic forms. Anybody else has any questions? Did you guys see the process? It's all about how you do the opposite. Does everybody follow me?
Yes.
Anybody who has a question? Anybody wish me to explain one more time?
Are you gonna go over the second one too?
Yeah, we're talking this over.
No, the bottom one, the one that says f of x is equal to
Yes,
negative f of
yes.
x. Oh, okay.
After all these are cleaned up. Okay. On the other hand, if I flip the purple, this purple over, what do I get? If I flip this purple over, what do I get? I get the red, right? If I flip the purple over, what do I get? I get the red, right? Yes, one is above x-axis. If I flip it over, become below x-axis. How do we express this red? That would be negative of f of negative x, right? Right, because the red, this red is the opposite of that guy. So I just put a negative sign in front of it. Yes?
Yes.
And these two are equal. And that's the second form. Yeah? Yeah, you got it?
Yeah.
You got it. Okay, then you just watch this piece over again. So next, if you still have a question, come back to me, okay? Now, with this said and done, right? All of these based on the assumption that this is x, this is a negative x, right? I can totally reverse it. I can say this is x and this is a negative x. And you have another, situation like that. And they're still the same. They're still the same, okay? No difference. Now the question is, if sine is in the place of f, what will happen? If a sine is in the place of f. In other words, the rule of sine is in place of f because sine is an odd function. We have recognized it, right? So we have all these general descriptions of odd function. If I put a sine in place, what will happen? Okay, so I'm going to write it. If this is x, this is a negative x, right? F of x now is turning into what? This is going to be what? This is going to be sine x. Right? That's going to be sine x. What is the negative of sine x? We know that if this piece flip over, we get over there, right? So the red flip over, that's going to be what? That's going to be negative of sine x. What is f of negative x? That's going to be sine of negative x. And what is this? This
Negative
is
sine of negative x.
that's right. Negative sine of sine negative x. Okay. And now we said they are equal. These are all equal, right? So negative sine x is equal sine of negative x. So that's the so negative sine x is equals to sine of negative x. And from this branch, from this piece, what we got, what we get, what is it? Is sine x is equals to what? Negative sine of negative x. These are the possible algebraic forms that is used. And of course, this statement is just basically saying this is an odd function. Sine is odd function, right? Sine is odd function. We did all of those examples in the table. What did we do? We confirmed that, didn't we? Look at that table we did yesterday. Look at the table we did yesterday. Okay, could you guys write this all down?
One quick question. So just to recap what you said for those last two, for negative sine of x and sine of x, that it means that it's saying that it's an odd function, correct?
Yes.
Okay, just want to make sure.
Yeah, you basically from here, you multiply negative sign on both sides. You get the second one. You can see that?
Mm-hmm.
Do you see that? If this is true, you multiply -1 on both sides, you get the next one, don't you? So these two are equivalent. They are equivalent. These two are equivalent. You follow me?
Yes.
Okay, so now I want you guys to write down this one and write down that one. Okay, this process is called abstraction. I know, I know. It's a little bit difficult to understand when you. So let's look at what we did yesterday. Okay, I want you guys to write all of these down, or do you take a picture, whatever you do. Okay, I'm gonna clean this up. Unfortunately, I have to clean them up. Okay, and we're going to go back to the table we worked with yesterday. You follow me? Did you take the picture or did you write it down? I think even after you take the picture, you should commit yourself to write them down as well. Okay, taking a picture is very different from writing down. Okay, so far so good. I'm going to clean up. What we did yesterday? We did that, didn't we? Did you guys complete the table? Well, this is your homework, so I'm not going to do all of it. I'm not going to do all of it. What does that mean? Right, so we just talk about this general form, all right? So sine of negative x, excuse me, is equals to negative sine x. With understanding of with understanding of all the meanings, right? With understanding of all the meanings we talked about yesterday. Okay, with the understanding of all the meanings, right? So this is x input, f of x. And the output is f of x. Over here, we have x first, and then we have a negative x. And then we apply the rule. Okay, so that becomes f of negative x. Okay? The the rule applies the same way. Just whatever the input, it produces an output. Whatever the input, it produces output. If the input is 2x, and this is going to be f of 2x. You guys follow me? If the input is negative x, and this is going to be f of negative x. Do you guys see that? That doesn't change. That doesn't change. Okay. All right. So with that said and done, as an odd function in this case, what would you write it down? Because f is sine, so sine of negative pi over 4 is going to be negative of sine pi over 4. That's what we got. That's the purpose we get to yesterday, is to get to this form and recognize this form and what it means. So far, so good? Everybody? And next, yes.
So for an example, let's say 5 pi over 3, you would put down sine of pi over 3 is equal to negative sine of pi over 3.
Right.
Okay.
Right. So in time, you would not need to do this. You just go straight there. You just go straight there. So all of these is just to show you this form is true for any x, for any input. We only have given you several of the input, right, to demonstrate the meaning of it. And say in this case, you're gonna, the opposite of 5 pi over 3 is 5 pi over 3, negative pi over 5 pi over 3, then you would know in this case, right, the x is chosen to be 5 pi over 3. All you have to do is just plug in. You follow me? And you will not need to do all of these. Do you guys understand? This last row, I mean, this last column is where we get to, is to understand this form. Yes, and of course, I want you guys to work out the details. You need to get used to the notation, right? You need to get used to the notation. And because I found that's one of the hardships of our student, they don't have that process of abstraction, you know, from individual form, from observation to the general form abstraction. Or some people know the abstraction form, but they don't know how to apply it. You follow me? So any questions so far? Am I spending too much time here? I might have. I never spent so much time here in a topic like this.
Do you think you can do you think you can go over cosine for even?
That's right. That's where we're going to for cosine.
Oh, okay then. My bad.
No worries. Yeah. So assume everybody get sine, right? Let's look at cosine. Okay. So did you guys do cosine yesterday? What have you discovered? What have you discovered? Have you done cosine yesterday?
That it's an even function.
That's right. It's an even function. So what will happen?
So it's going to be cosine of pi over 6 is equal to cosine of negative pi over 6.
That's right. And that's going to be true for any inputs, right? So A, it doesn't have to be pi over 6. They apply to all of these, right? The final form. So that final form is a cosine of negative x equals to cosine of x. So what does it mean? It means that if the input are opposite, the output are the same. That's the feature of cosine. Okay, so let's bring this over up there. You guys still need to do the homework, okay? So now let's look at cosine. Let's look at cosine. Okay, the cosine curve. We all know the cosine curve, don't we? That's a cosine curve. That's the cosine curve. Okay, so I'm gonna make it -7 here, +7. So that's the cosine curve. Right? Cosine curve. Everybody knows that, right? We talk about how it works, right? The input horizontal is the arc length of the piece on unit circle on the from the standard position to the terminal, right? So we have explained that. Now, if you look at suppose we look at two pieces of input, right? They're opposite to each other. Inputs opposite to each other. Okay, so input, whoops, I'm gonna use different color. I'm gonna use blue. Okay. Input opposite to each other, x, negative x. Okay, and what's their respective output? Their outputs are the same. My drawing is not that super good, right? There. When the input are opposite to each other, right? If this is x, let me change the color. If this is x, and that's negative x. And if this is x, and that's negative x. Do you guys follow me? They're always opposite to each other. They're always opposite to each other. You just take one case and their output are exactly the same. Exactly the same. That's the feature of odd function, and a cosine is such a function. It's an even function. I'm sorry, that's a feature of even function, and a cosine is such a function. You follow me? So the table we have you done yesterday is to see that, right? Is to see that not only from the unit circle, you also see it from the curve. In fact, the cosine curve is symmetrical with respect to the y-axis, right? With respect to the y-axis. Are we good? Yes?
Yes.
All right. So do you have any questions about the cosine table that was assigned to you yesterday? Yes or no?
So, and sorry about this. So another example would be like, f or cosine of -π/2 is equal to cosine of 2π/3, right?
Can you write that down so everybody can see? Are you writing it down?
Yeah, can you give me a second? Sorry.
Oh, no worries. Take your time. Right now I'm drawing this for you guys to see. Okay, there's no rush. Okay, so 0, 0. Here we have a
It's meant to be cosine, not sine, by the way. Sorry about that.
cosine. Yeah. So when you write it down, you know yeah. So when you write it down, it will just make it so much clearer. You know what? Right? It just make it so much clearer. So when you write it down like this, what you see on the chat actually is wrong. Right? So can you rewrite it?
Oh, I see where it.
Please, right? Because when you write down an expression, it's either right or wrong. A mathematical statement is either right or wrong. Yep, that's perfect. Except on the end, you didn't close the parentheses, but that's okay. Okay. If you write that on a piece of coding, then your program is not going to run. Okay, syntax. But anyway, that syntax error usually is easily corrected by debugger. But you can see the first one. Could I mark there? Right. The first one is wrong. No, it doesn't mark there. Right. So I'm going to copy Jacob's work. Okay, you don't mind, right, Jacob? Okay, thank you for your contribution. Right? This form is right, and this is wrong. Does everybody follow me? And of course, here, I need to close the parentheses for you. I need to close the parentheses for you. And this is always true, no matter what's the input. That's what we need to understand. No matter what's the input. So when you put any particular input, it's going to be true. When you put any general input, as long as the input are opposite to each other, and they're always right. So how do we correct the first one? How do we correct the first one? Okay. How do we correct the first one? So I'm gonna change this to the better looking algebraic form. Okay, so this is gonna be sine of -2 pi over 3. Okay, I want you guys to think of the corrections to the first one. Right? You guys make a correction. The second one is correct. Okay, I'm just going to copy his. Okay. As is given. The first one is wrong, the second one is right. So can you make a correction for the first one? What are the forms of correction could there be?
Okay, I think I fixed it, I believe, my own problem.
How can you correct this based on the form? So suppose you're me, you're grading some student's work, right? You wish to tell the student that this form is wrong. Okay, this form is wrong. But you also want to show the student at the same time what's the correct with a minimal stroke. With a minimal stroke, what would you do?
Well, first, I would probably tell them to change the sign to cosine and then switch around and make the first sign positive and the next one a negative with parentheses on it.
Well, that's a lot of stroke.
Yeah,
okay, so my correction would be I put a negative sign in front of it, or I put a negative sign on this side. That's the correction. Okay. You see that?
I see.
That will fix it. That will fix it. missing of a negative sign. You can either put a negative sign here, you put a negative sign there. That will make it right. But this is
So
wrong.
that would be an example for odd function.
That's right, because sign is odd,
Yes,
right?
yes.
Have you seen similar questions on the last quiz, quiz number 12? I did give you some questions like that, didn't I? Of course, at that time, you haven't learned about even odd or you have forgotten about it. You have to go through ARD. Right? You follow me? What Jacob just said is a way to correct it, right? It's okay. But to minimal, I usually when teacher, well, to speaking for myself, when I grade your work, I usually try to maintain the integrity of your work and make minimal changes to your work to show you the correct work. If I can do it, In this case, I would just either, right? This way of writing, of course, we know that's wrong. If I were to correct your work, I will either put a negative sign in front of it or put a negative sign on this side. That's it. -2, minus whatever point I will minus for such a work. Does that make sense to everybody?
Mhm.
Even function, okay? Even function. So this way you understand what even means, right? So even means that whenever, so now we used to see so much things, right? We saw the even function x squared, right? And we saw cosine is even function. How about the exponential logarithm? Are they even? Are they odd? Have you thought about that? Are they even or are they odd? Okay, I'm not gonna go there in class. Okay, that's gonna take too much time. You think about it. Okay, among all the functions now we have introduced even, odd. If you look at all the functions up to this point, from the first one to cotangent, you look from an even, odd perspective, what do you see? Right? So that's what you are expected to study as a student. Your professor doesn't cover everything, but give you like introduction or something, and you are expected to do it. But if you don't do it, you're going to see something like that on the exam. You guys understand what I'm saying? And that's going to be the same for calculus classes. Your professor will be doing something in classes with some examples and stuff like that, and then he or she give you homework, and then you need to how to thoroughly study these things, right? Is you need to expand your the study, maybe at least the homework, maybe a little bit more, in order to cope with that exam, which is you require a little bit more work. Do you understand what I'm saying? Okay, so you need to take this concept to exponential functions, logarithm functions. Are they even? Are they odd? And you do some studies yourself. Okay. All right. So without further ado, let's look at tangent, cotangent. I'm not going to do both tangent and cotangent. Okay, because of what? Because they're similar in terms of even, odd, right? So let's look at tangent. You have a table for tangent, you have a table for cotangent that was given to you yesterday, right? I can also create a secant and cosecant, but why I didn't? Well, cosine, if cosine is even, secant is even. Secant is cosecant is odd, or sine is odd, so cosecant is odd because they're reciprocal to each other, right? Yes. So that's not difficult for you to figure out. And even though I don't address those things in class, but you should think of it as a student, as a student. You must. Okay. So what I'm addressing here in this piece of the lecture is I'm basically telling you how to study. Okay, it's true. It's a lot of work. But sometimes the work is not given to you. You have to go find it. And if you go find it, you'll find a lot of them. But if you do that study ahead of the exam, ahead of the whatever it is, that's how you ace it. Okay, you can't wait to say, oh, I'm going to do the exam and I'm going to think on the spot. And I didn't have to, I can all go ahead, party and the beach and everything. Then I can just think on the spot to do math. I cannot do it. I know I cannot do it. If you can, you're a genius. Right? All right, so let's look at tangent. Tangent x. We have that table, right? What did you discover? Have you guys tried them? You guys need to do this homework, okay? Because they're going to show up. On your quiz this week. Okay, they're going to show up on your quiz this week, right? So what I'm trying to tell you, all right? What we're trying to do. Now, tangent curve, you can get it at fingertips. You can get it at your fingertips, right? So if I put this in the perspective, okay, that's a tangent. Is this even or odd?
It's odd.
I'm sorry?
It's odd, right?
Yep, it is odd. Okay, it's even or odd. Actually, to determine the even or odd property about tangent, it's much easier to work with the definition. It's much easier to work with the definition because tangent equals to sine over cosine. Right? Yes? We know that, right? Okay, so then you just go by the definition. So let me bring back up the definition. I want to show you how important it is to know these definitions. That's why I asked you guys to put them on the flashcard. So these general forms is to be understood. They are to be understood. But once you understand it, you have to know how to apply them, right? So now because I don't know it's even or odd, so I'm going to start with f of negative x. Right? F of negative x would equals to what? Tangent of negative x. Okay, so you have to be able to not only recognize the geometry, the visual, you also have to, most importantly, be able to express it algebraically. That's what gets you the points. Okay, so sine of negative x is going to be the sine of a tangent of negative x is going to be sine of negative x, so cosine of negative x, right? And now sine is odd. Odd means it's a negative sine x. Cosine is even, so it's going to be the same as cosine x. So in the end, you get a negative tangent x, which is negative of f of x. Okay, so f of x, so tangent of negative x is equals to negative tangent x. Okay, just on these notations, I can make 2, 3, 5 questions for you. Right? And the table gave you the example to show, you know, what it means, right? And the unit circle expressions, you can make those connections like that. You guys follow me? So there's a lot of connections to be made when you study. But anyway, tangent is odd, right? So from here, you can tell, of course, x must be in the domain. What's the domain of tangent? What's the domain of tangent? Yeah, what's the domain of tangent?
It is a cannot equal to 2k plus 1 over pi over 2.
Right.
Was a different one.
Odd number multiples of pi over 2. Odd number multiples of pi over 2, right? 2k plus 1, odd number multiple of pi over 2. Okay, so when you read those mathematical expressions, you want to inject your meaning, inject the meaning to that reading. All right, now, so that has demonstrated tangent is odd. Is tangent really odd? What's the criteria? How do you view this picture? The same story, okay? So now I want you guys to try to draw the similar pictures I drew for sine and cosine and to see for yourself, shall we? Yeah? Are you guys with me? Can you try to draw that? So you get those pictures for yourself, right? They're at your fingertips. Tangent curve. Who doesn't have access to tangent curve, right? It's available usually on any particular, any decent calculator, right? X, negative X, and what the output? The output the red, right? So this is going to be the same for so I'm drawing these just to show you. Do you see similarity? And then you can do the, you know, the negative, and you just play with the opposite. What's the opposite? The opposite of the blue, right? The blue express the opposites, right? You guys follow me? If this is X, and that's a negative X. Horizontal measurement from the same point of reference, right? If this is a negative X, and that's X, they're just opposite. They're just always opposites. I don't have to use X, I can use other symbols, right? And the output are opposite. Opposite means what? If I flip over, they're going to be the same. If I flip over that, they're going to be the same. You guys follow me? If you do this just a couple times, then you get it, don't you? But if you have never done it, it's hard. It is hard. I agree with you. It's hard if you don't do it. Okay, so these two red, even though they have the same length, but they're opposite in sign. They're opposite. You follow me? All right, so I think that's enough about even odd functions. Oh, what did I do? Did I delete it? Oh, I delete that curve. Oh, man. How dumb is that? I spent all that time to do it. Ah. Okay, let me see if I can quickly reestablish it. Okay, do you have any questions? Do you have any questions? Yes or no? Oh, I hate this, don't you? Don't you? Okay, so I'm gonna take your questions, okay? I'm gonna take your questions if you have any. Otherwise, we're gonna move forward. Okay, we can't do well on this forever. Okay, it's the blue and the one red. So I should make one purple, one red. All right, all right. Okay, purple, red. Make this red. So with that said and done, shall we do a little summary here about even odd function property? Can we have a breakout room so we can do a summary on our own before we get together?
Professor, I'm here if you want to
You guys
create.
want to take the initiative? Yeah, Farouz is here to help. Because I want you guys to eventually learn how to do summary yourself.
You can show us one of the line of the summary table, then we can work on the other ones.
Okay, so let's do that. Let's do that. I won't be there to do the summary for you in your calculus class. I will not be teaching a calculus class. Okay. Just in terms of even odd, okay? So sine X or sine A, whatever, cosine, tangent, cotangent, right? I can put A there if you want. It doesn't matter. We use X, let's use X, okay? We know their domain range. So sine is odd. Cosine is what? Even. Okay. Now, we know all of that. Tangent is odd. We just did it, right? And next, I want you to summarize about cosecant, even odd about cosecant and secant. And you also need to write down that algebraic form. Okay, so you're going to fill out these empty space. Okay, the algebraic form, right, for odd function, right? For odd function, the the algebraic form is f of negative x equals to negative of f of x, right? Or f of negative x, f of x equals to negative of that. These are the two forms, okay? How about for even? Even is pretty simple, right? It's just f of negative x equals to f of x. All right? So what you need to write down here, okay, we have the example for a cosine. Equals to sine of x. Oh, sorry, cosine. My bad, cosine. Okay, so these are the examples, right? Even function means that is true. For what? For all x in the domain. Okay, then domain of cosine is from negative infinity to positive infinity. Okay, so even odd, the line below. All right, so algebraic expression, algebraically. Okay, just algebraically. And domain, right? That property in where, right? So I basically covered on the even odd, we basically go by the definition of even odd definition, right? So we follow the even function, odd function on the domain, right? It's a definition, the definition, okay? So now what you need to fill out, you need to fill out all the blank. Okay, I'm gonna give you 5 minutes. Would that be, do you think that might be enough, Farouz?
We try.
I will add more time, you let me know, okay?
Right.
Okay, the room is open. So this is the work to be done, the blank. The blank about even, odd, about all these functions, right? You know the definition, and we want you to write down the algebraic form. Right? So we don't need that anymore. Oh, we can just put it there. We don't need this one anymore. Okay, the odd one has 2 forms. Okay, so 5 minutes.
That would be easy, probably. Just you want the algebraically form of the expression and the domain for all
Yeah.
those rest of the trigonometric functions.
Basically, yeah, we have a narrative using these definitions describing these algebraic form for what kind of inputs, okay? All right, you can certainly attach your graph to it.
And I remember you mentioned, for example, if the cosine is an even function, it's reciprocal. Secant is also even function.
I'm glad you heard it.
I'm watching the breakout room. Nobody's there yet, so I'm waiting. Any
Yeah, I
interested
believe,
people?
yeah, everybody's working on it.
Okay,
Okay, I'm just gonna get something to drink. I'll be right back.
sure. So anybody want to contribute to filling this table? Maybe Jacob is very active responding to professor's questions. So maybe Jacob can build up some confidence on rest of the class. So I'm ready with my board on the breakout room or here. You can also here respond. We can fill up the table. So either way, here or breakout room. I go muted. Let me know if you have, if you want to fill up the empty cells in that table.
All right, how's it going?
So I'm here, Professor. I did, let the student ask if they have question, and then I went fill up the table in case if anybody has question, we want to match our table, So for the sine, cosine, and tangent, I did copy the way you wanted us to copy, giving the example for cosine.
Okay.
So I was waiting to see if we can, if we can match with our answer with the class, but the time was up, 5 minutes.
All right, time is up, right? We already
Yes.
passed. Okay. Thank you very much. All right, so sine is odd, right? But cosecant is the reciprocal of sine, right? right? Of course, cosecant has its own domain, right? So we can take this opportunity to review what's the domain of cosecant, right? That you'll be asking the question, what makes sine equals to 0, right? It cannot be. So you should you should be familiar. I'm not asking you guys to memorize, okay? I'm not a big fan of memorizing these facts. I'm a fan of reason yourself through the process. Reason. Okay, reason. All right, so whatever makes sine equals 0, you can use whatever. We have gone through that, right? So that's a domain. So because of this property, so cosecant x, right? So cosecant of negative x, what will happen? It's going to be equals to what? 1 over sine of negative x, right? And sine is odd, right? So sorry, I should put it here. Sine is odd, right? So here you're gonna have negative sine x under 1. And that's just going to be negative. You can put the negative sign in front of it, right? You can put the negative sign in front of it. Same thing. So that's a cosecant x. So cosecant is odd. Okay? It's just for the odd function sine, it's going to be in the entire domain of sine. For this one, for cosecant, what would it be? X can be any number but k pi, right? Where k is an integer, right? You recall all the process, you could recall that process, we did that. And secant, right? So cosecant is what? It's odd. And cosecant is odd and cosine is even. Similar, right? Would that be similar? Right? So secant of negative x would equals to what? 1 over cosine of negative x. And that's going to be the same as 1 over cosine x because cosine of negative x is the same as cosine x. So this is going to be secant x, okay? And that's going to be related to the domain for secant. What's the domain for secant? Whatever make the denominator equal 0, those numbers must be out of the domain for secant. So what are those? Odd number multiples of pi over 2, right?
I was going to say 2k plus 1.
That's right, right? X cannot be. Do you guys see the logical connections that I've been trying to, that's what I've been trying to show you. Otherwise, I don't need to spend all this time with you guys addressing and going through these process. I can just give you the answer, right? Just give you the answer, give you the tables. So you can just bang your head to memorize it. Do you want to do that? I'm sure you don't want, because I don't want that. Right? So I do unto others what I wish to be done to me. Right? On my bookcase, it says, do to others as you would have them do to you. I don't want to do that. So I won't do that to you. I do to you that I wish, others would do to me on this subject of math, right? And tangent, and as we had previously, we have summarizes about these things, right? You can see tangent is sine over cosine, right? It's sine over cosine, because we can bring all these connections. You can see how much connection could there be, right? So you have a cosine as a denominator. So this guy has the same domain as secant. k is the integer. Do you guys see that those connections are built naturally? In this process, if you go through this process with me, you don't have to memorize a lot of things anymore. Okay, you don't have to memorize all these things anymore. And we have already addressed that tangent of this is odd function. And cotangent is something we haven't done, right? Cotangent is something we haven't done. Is it even or odd?
Odd.
Yep. You already figure out, right? From all these we have done, cotangent is just cosine over sine. That's why we're not going to cover those, because you just have to think about it, right? And you get it. So cotangent of negative x is equals to negative cotangent x. And with what the domain is a cotangent talking about, domain of cotangent is the same as cosecant. There. Boom. So now we address the definition of even function, odd function. So whenever you mention even function or odd function, we need to be mindful of the domain. It is even or odd or neither. That's related to it. Right? Any other questions? And so what are those tables about? Well, those tables I have you guys done the homework yesterday is just to give you specific values for those inputs, so that you work out, and see for yourself. But anyway, so we covered even odd, I think, very thoroughly. I actually have never covered even odd function this thoroughly, to be frank with you. Okay. You can watch my former videos, and then I've never covered even odd this thoroughly. But anyway, I think I feel good about this coverage. Do you have any questions about this? And this time, yes.
Sorry. So if we wanted to, can we for tangent and secant, can we also say all real numbers except 2k plus 1 part over 2 that k is an integer?
Yes, that's
Okay.
what it means. That's how it should be read. All real numbers except, all real number except, all real number except.
I see. Okay.
This is a common practice of shorthand notation in mathematics. When they write something like this, that's what it means. Okay, I'm glad you bring this up, Jacob. I think I probably just write it down the words. Oops. Oh, I did something stupid. Okay, I think for your clarification, Jacob, I think I should write it down. How to read it, right? I should write it down, how to read it. I have realized that, well, a long time ago, right? Long time ago, I realized I cannot assume my student have the same background as I do. Okay. Of course, right? You guys just like one of the students, I was just one of you. Well, that was many years ago. So I try to cover everything that I can think of that might be a question. So when you bring up things like that, like Jacob just bring that up, I really appreciate it, because sometimes I might just overlook certain things. All right, so that I'm gonna make this. So how to read it? All real numbers except. Would that be satisfying for you? Would that be helpful for you?
Mm-hmm.
And I appreciate Jacob bring that up, because I just overlooked that. I thought you guys knew. Well, you may or may not know, okay? So when we write something like this, it always meant that, okay? It basically says all real numbers except. I think the except is this would turn into equal, right? Would that be proper grammar-wise? Yes? So this will be all real numbers. All real numbers. All real numbers. Right? And here, the same thing. All real numbers except. But when I say except, should I have the equal or not equal? I think to be correct, I should have equal. Yes? Correct me, please. Are you guys with me?
Yeah, I'm just trying to see if you need it or not.
Any other questions for me to clarify? Yeah. So at the same time, we review the domain. Because in the definition of even odd function, the domain is addressed. The domains are addressed, right?
So, Professor, question, are we supposed to learn this table or we are allowed to use it on the quiz exam final? What is our responsibility as a student?
Oh yeah, anything I covered is possible on the show up on the quiz or the exam.
So we need to learn it, practice, learn it, and download it from our memory into a piece of paper if we see it is, which is useful, right?
Right.
So we are not allowed to have it, this kind of reference sheet on our quiz or exam, do we?
Better not. It'd be better
Okay.
not. Better for you not, right?
Yes.
But I mainly want you guys to see the logical connections, the logical relationship. Because as I always address to you guys over and over again, it's not about memorization. It's not about memorization at all. In fact, if you have to memorize the tables we have done so far, you're going to be frustrated. You're going to hate me. You should.
We are going to hate math science, not you.
Why don't you just say, Jesus Christ, look at this woman give us all these tables to memorize. No, that's not the point. That's not the point. Okay. So when I prepare those quizzes for you, I was hoping that you guys gonna watch the quizzes. You watch those lectures at least 3 times. Before you take the quiz, you watch the lecture. After you take the quiz, you watch the lecture. You know, after you take the quizzes 3 times, you watch the lecture at least 3 times. But that time, you should understand the lecture very well. So then my point is for you to understand the lecture and its logical connection in the contents. That's my objective. I have no secret mission in my mind. No, not at all. The lecture is the part I sharing my own experience and how, you know, they're all connected, how you understand the connection, and then you don't have to memorize a thing. You can just go somewhere, on vacation, still taking this class online, right? And you understand, you don't need to even bring a book because you understand the logical connection. You watch the lecture, you understand, but you need to watch it over and over. I don't know how many of you guys actually watch it over and over, but I guarantee you, if you watch it over and over, you're bound to ace every quiz. Do you guys agree with me? If you don't understand how to do the quizzes, number one reason you haven't watched the lecture enough. All right. So we're approaching the end of the class, but we finally will get to the door. We're going to cover inverse function, inverse trig function, right? Inverse trig function. As we go back to the question, right, you can see sine, cosine, all of these functions, right? Sine, cosine, all 6 trig functions. None of them is one-to-one. So none of them has an inverse. The inverse does not exist for them. So for these 6 functions, sine, cosine, tangent, cotangent, secant, cosecant, as we know them, they don't have inverse functions. Do you guys follow me?
Mhm.
They don't. Even after we cover the inverse function, they still don't. So we can safely say all these 6 functions we just talked about, none of them has inverse. But then where did the inverse trig function come from? Well, those inverse functions are for something else. For some new functions established based on the existing function. Okay, so now that's what we're going to talk about. So today we have a couple minutes left, right? So first, let's just write down sine, cosine, tan, cotangent, okay, secant, cosecant. Okay, these functions okay, I would say none of these functions is one-to-one. Thus, none of them has an inverse. Period. They don't. Okay, I want you guys to write down this sentence. They don't have inverse. They never had one, and then they never will. But what is the inverse function we're talking about? Well, in the case of sine, right? We know the curve of this function, right? It's a periodic function. You learn, in trigonometry, right? It doesn't pass the horizontal line test. It passes the vertical line test that makes it function, but doesn't pass the horizontal line test. Therefore, it's not a one-to-one. But what do? We basically make some modification to this function. What we do is that we look at this entire curve, right? We look at this entire curve. So I'm going to make the bigger pieces here, right? So I'm going to make it say 10 here, right? This is sine curve. We look at this, this one going up and down, but if we can make some pieces, right? Suppose I take this piece. Suppose I take this piece. this piece is a decreasing function, right? It's a decreasing function. Therefore, it's 1-to-1. So 1-to-1, this piece has an inverse. Or another option, I could be taking this piece. I could be taking this piece, right? This piece is increasing. Increasing function is 1-to-1. Therefore, this piece has inverse, okay? And the process keep going, right? I can have another piece, this piece. So I have so many different ways to get the pieces of this sine function as we know of. And this piece is decreasing, therefore it's 1-to-1, therefore it has inverse function. But these pieces are no longer the whole. These pieces are no longer the whole. They are just a piece of the whole. So what is a piece of the whole? So we decide we're going to choose the simplest piece possible. We're going to choose the simplest piece possible. And that piece turned out to be, okay, I'm going to drop all of these. I'm going to drop all of these. Okay, all of these pieces are dropped. I'm going to drop all of these pieces, right? I'm only leave this piece with the heart. I love this piece. So this piece to me is the simplest possible. And this function, however, is no longer the same as the sine we knew, the sine we know, okay? And this creates a new function. This new function, we're going to specify that x is going to be between -pi/2 to pi/2. This function is no longer the same function as we know by the name of sine. Do you guys follow me? They're not the same. Why they're not the same? Because their domain are not the same. So whenever we address sine, we always refer to that sine with domain as all real numbers. You guys follow me? So that's the introduction to inverse trig functions. I will put quote and unquote inverse functions because they're very specifically defined. And we're going to work on that tomorrow. We're going to work on tomorrow. So today I'm just giving you an introduction. It's just this piece. That piece is not the whole. The whole is much larger than the piece. But for that piece, we have the 1-to-1 property, and therefore we have that inverse. You guys follow me? So I want you guys to walk away from today's lecture with that message, which is very, very, very important. I will see you guys tomorrow.
Thank you, Professor.
Thank you.
It's Chan.